Article 334.10 of the National Electrical Code addresses cable trays. MC cable is permitted in cable trays in any occupancy. Article 334.10 pertains to hazardous classified locations. MC cable is permitted in Class 1, Division 2 and Class 2, Division 1 and 2 hazardous classified locations. Article 334.10(3) addresses other occupancies. MC cable is permitted in all other occupancies, including industrial occupancies, assembly occupancies, educational occupancies, residential occupancies, and business occupancies. Article 334.10 concerns dwelling units and guest rooms. MC cable is permitted in dwelling units and guest rooms in accordance with Article 334.10. The architect's statement that any building with planned occupancy more than 200 has to be done in EMT is incorrect. The National Electrical Code does not restrict the use of MC cable in buildings with planned occupancy exceeding 200. MC cable can be a more cost-effective wiring method than EMT, especially for long runs or where flexibility is required. It is important to consider the total cost of installation, including materials, labor, and permitting. If you have concerns about the architect's restriction, consider the following. Firstly, discuss the National Electrical Code requirements with the architect and provide supporting documentation. Secondly, consider the cost implications of using EMT versus MC cable. Thirdly, contact the local building department to confirm the applicable code requirements. MC cable, or metal-clad cable, is a factory-assembled cable consisting of one or more insulated conductors enclosed in a metallic sheath of interlocking tape or corrugated tube. It is a versatile wiring method commonly used in both residential and commercial buildings for power, lighting, and control circuits. Its flexibility and ease of installation make it a popular choice for various applications. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in technology and best practices. Adherence to the NEC is essential to ensure the safety of people and property. Occupancy classifications in the NEC categorize buildings based on their intended use. These classifications determine the applicable electrical requirements for each type of occupancy. For example, assembly occupancies, such as theaters and restaurants, have different electrical requirements than residential occupancies, such as apartments and single-family homes. ENT, or electrical metallic tubing, is a thin-walled conduit commonly used to protect electrical wiring. It is typically made of steel or aluminum and is available in various sizes. EMT is a rigid wiring method that requires specialized tools and fittings for installation. It is often used in commercial and industrial applications where greater protection is required for the wiring. When comparing the cost of MC cable and EMT, it is important to consider all factors involved, not just the cost of the materials themselves. Labor costs can vary significantly depending on the complexity of the installation and the skill level of the electrician. Permitting fees can also add to the overall cost of the project. In some cases, MC cable can be a more cost-effective option than EMT due to its ease of installation and reduced labor costs. However, in other cases, EMT may be the more economical choice, especially for simple installations with short runs of wiring. The local building department is responsible for enforcing the NEC and other applicable building codes. It is important to contact the local building department to confirm the specific requirements for your project. They can provide guidance on the proper wiring methods, materials, and installation techniques. In addition to the NEC, there may be local amendments or regulations that further restrict or modify the use of certain wiring methods. Metal-clad cable offers several advantages over other wiring methods, including its flexibility, ease of installation, and resistance to physical damage. It can be bent and shaped to fit around obstacles, making it ideal for use in tight spaces or where frequent changes in direction are required. MC cable does not require specialized tools or fittings for installation, which can save time and labor costs. Its metallic sheath provides excellent protection against physical damage, making it suitable for use in areas where the wiring may be exposed to impact or abrasion. However, MC cable also has some disadvantages compared to other wiring methods. It is generally more expensive than non-metallic sheath cable, such as an M cable, and it may not be suitable for use in certain hazardous locations. MC cable also requires proper grounding to ensure electrical safety. The NEC specifies the grounding requirements for MC cable in Article 250. Proper grounding is essential to prevent electrical shock and to provide a path for fault current to flow back to the source in the event of a short circuit. The grounding conductor in MC cable must be properly sized and connected to the grounding electrode system. The metallic sheath of MC cable can also be used as a grounding conductor, but it must be supplemented by a separate equipment grounding conductor in certain situations. It is important to follow the NEC requirements carefully when grounding MC cable to ensure electrical safety. When installing MC cable, it is important to use the proper fittings and connectors. The fittings and connectors must be listed for use with MC cable and must be properly installed to ensure a secure and reliable connection. Do not use pliers to tighten the connectors, as this can damage the cable and compromise the connection. Use a torque wrench to tighten the connectors to the manufacturer's specified torque. The NEC also specifies the requirements for supporting MC cable. MC cable must be supported at intervals not exceeding 6 feet and within 12 inches of boxes, cabinets, and fittings. The supports must be designed to prevent damage to the cable and must be securely fastened to the building structure. Do not use wire or cable ties to support MC cable, as these can damage the cable over time. Use approved cable supports, such as cable straps or cable clamps. When pulling MC cable through walls or floors, it is important to protect the cable from damage. Use a cable bushing or a cable sleeve to protect the cable from abrasion as it passes through the opening. Seal the opening around the cable with a fire-rated sealant to prevent the spread of fire and smoke. Do not pull MC cable through holes that are too small, as this can damage the cable and compromise its insulation. When terminating MC cable in boxes or cabinets, it is important to strip the outer jacket of the cable carefully to avoid damaging the conductors. Use a cable stripper designed for MC cable to remove the outer jacket without nicking or cutting the conductors. Leave enough conductor length inside the box or cabinet to make the connections easily. Do not strip too much insulation from the conductors, as this can expose the bare wire and create a shock hazard. When connecting MC cable to devices, such as receptacles or switches, it is important to use the proper wiring techniques. Connect the conductors to the terminals of the device according to the manufacturer's instructions. Tighten the terminal screws securely to ensure a good electrical connection. Do not over-tighten the terminal screws, as this can damage the device. When splicing MC cable, it is important to use approved splicing methods. Use wire connectors listed for use with the size and type of conductors being spliced. Twist the conductors together tightly and then screw on the wire connector. Make sure the wire connector is properly sized for the number and size of conductors being spliced. Do not use electrical tape alone to splice MC cable, as this is not a reliable splicing method. When working with electricity, it is important to follow all safety precautions. Turn off the power to the circuit before working on any electrical wiring or equipment. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can be dangerous if not handled properly. If you have any questions about the NEC or other electrical codes, consult with a qualified electrician or electrical inspector. They can provide guidance on the proper wiring methods, materials, and installation techniques. Do not take shortcuts or try to save money by doing electrical work yourself if you are not qualified. Electrical work should always be performed by a qualified professional to ensure safety and compliance with code requirements. Remember that electrical codes are constantly evolving, so it is important to stay up to date on the latest changes. Attend continuing education classes and read industry publications to stay informed about new technologies and best practices. By following the NEC and other applicable codes, you can help to ensure the safety of people and property. MC cable is a versatile and reliable wiring method that can be used in a wide range of applications. When installed properly, it can provide years of trouble-free service. Take the time to learn about the NEC requirements for MC cable and follow them carefully. The architect's restriction on the use of MC cable in buildings with planned occupancy exceeding 200 is not supported by the NEC. MC cable is permitted in all occupancies, including assembly occupancies, educational occupancies, residential occupancies, and business occupancies. If you have concerns about the architect's restriction, discuss the NEC requirements with the architect and provide supporting documentation. Also consider the cost implications of using EMT versus NC cable. NC cable can be a more cost-effective wiring method than EMT, especially for long runs or where flexibility is required. Finally, contact the local building department to confirm the applicable code requirements. The local building department can provide guidance on the proper wiring methods, materials, and installation techniques. By following these recommendations, you can ensure that your electrical installation is safe, code-compliant, and cost-effective. Remember, safety should always be your top priority when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before starting any electrical project.